Hi, this is Team 28 for Neural Networks. The motivation and problem statement for our group project is to automate the detection of COVID-19 and pneumonia by looking at chest X-ray of lungs. If we cannot detect any of those, that means they belong to a patient with normal lungs. And a final goal is to develop a final tuned ResNet model with hyperparameter tuning and transfer learning for automating this detection. Our data sources are two publicly hosted datasets on Kaggle. The ADA on these data sources specified that there exists a class imbalance, which we countered by doing oversampling, augmentation, and adjusting weights to account for the lower number of COVID-19 cases. These are samples of COVID-19, pneumonia, and normal images specifically. Moving on to some things about the ResNet model. It's a deep neural network with residual blocks and identity functions. And the good thing about it is that it overcomes the vanishing and the exploding gradient problem by having the identity function, as well as its loss graph is much smoother as compared to a dense neural network without any residual block. Our current model uses some methodologies as follows. We do augmentation, such as slight resizing, normalization, shearing, grayscale, and brightness contrast adjustments. Care has been taken to avoid any changes in the anatomy of the X-ray since they're medical images. Also, the resizing and the change in the number of channels has been done keeping an account the specifications of ResNet model. We have a 75 to 25% train test split with an SED optimizer and accuracy F in score precision recall as metrics. Our baseline model is a vanilla neural network with some regularization techniques such as dropout, L1 norm, etc. But we had a higher than realistic score in which our model overfit, and the causes were that there was a lack of variety of X-ray in our dataset and a high number of incorrect labels in the second Kaggle dataset. And we can verify these results because the graph for model loss and model accuracy does not resemble what the graph looks like for an ordinary neural network. Again, the confusion matrix shows that there exists a bias for COVID-19 images. That means the model does not give the correct prediction. Moving on to our current model performance, the accuracy achieved is 96.43%. And as seen by the confusion matrix, there is no such bias for any class. The per class accuracy is almost the same, which means that the model is fair and well generalized. The training loss seems to resemble the loss curve for any neural network, which starts off high, goes on low, and keeps on decreasing with each epoch, and there is no sharp decrease anywhere. Again, the confusion matrix shows here some bias with pneumonia, but that's just because we have higher number of pneumonia cases, but the weights have been adjusted. Some things about ResNet here. Initially, we were getting zero validation. That means the model was not learning. This was because we were using CPU instead of GPU, and since there were so many large number of images, the RAM was filled and the data was leaked. What we felt is that the data was fed to the cache but not be able to retrieve back because the RAM was already filled. But after this point, we shifted to GPU and using data loader of PyTorch, in which data was directly transferred to the GPU and taken back from the GPU, which meant no data loss. And after using that, a model started learning and had a 96.43% accuracy. So in this project, we also had some system-wise challenges, which we overcame. Members of our team have had experience with course CSE 522 and CSE 591, Trustworthy and Efficient Deep Learning, with some experience in CNN, PyTorch, and ResNet. These are our references for Kaggle. Thank you.